This theorem narrows down the search for maximum or minimum points of a function. We will call the maximum or minimum extremum. Okay. So if we have f of x that has a local or absolute extremum at c, that point c must be either a critical number of f of x, okay, or it must be an endpoint of the domain of f of x. So this is very good because it's saying that if you want to find the local or absolute maximum or minimum of a function, all you need to do is to check for the critical numbers and endpoints of the domain, which really narrows down the search to just a few numbers. Now, one thing that we need to be careful, we need to remember that extrema do not necessarily exist. Do not necessarily exist. Okay. Let's see one more theorem that says a very easy condition that we can check and guarantees that there are extrema. So this is what is called the extreme value theorem. Okay, and it says that if f of x is continuous, on a closed interval AB, then f of x has both an absolute maximum and an absolute minimum. Okay. And these are to be found in A, B. So notice here we have two hypotheses. First, that f is continuous. And then the second part is that it's on a closed interval AB. Okay, so those are two important things. The function needs to be continuous and the interval needs to be closed. We will see in a moment the reason for that. Now let's see some examples. Let's look at f of x, that is x squared plus x, on the interval -2, 2. Okay, the extreme value theorem says that because f of x is a polynomial which is continuous, and the interval -2, 2 is closed, then there will be an absolute maximum and an absolute minimum. So let's find them. The previous theorem says that to find those absolute maximum and minimum, we just need to check the critical numbers and the endpoints of the domain. So let's go for it. F prime of x is 2x plus 1 equals 0 if and only if x is -1/2. Okay, this is a critical number. Because the function is differentiable, that this is the only critical number. Okay, and we need to check by the extreme value theorem. We need to check -1/2, which is the critical number, -2 and 2, which are the endpoints. So we just compute the value of the function at those points and see what happens. So f of -2 is -2 squared plus -2. That means 4 minus 2, that's 2. Okay. F of -1/2 is -1/2 squared minus, well, plus -1/2. That's 1/4 minus 1/2, negative 1/4. And then f of 2, which is 2 squared plus 2, which is 4 plus 2, 6. So when we look at these values, we see that the absolute minimum will happen at x equals negative 1/2, and the absolute maximum will happen at x equals 2. Okay, and the minimum value of the function f will be negative 1/4, and the maximum value of the function f will be 6. Okay. Now, careful here because the theorem fails for discontinuous or open intervals. Okay, the extreme value theorem fails for discontinuous functions or open intervals. For example, I could take the function f of x equals x squared plus x, okay, in the real line, negative infinity, infinity. This is considered open, okay, and in this case, there is an absolute minimum, but there is no absolute maximum. Okay, where is the absolute minimum? The absolute minimum is at x negative 1/2, okay, which is the point where f prime is 0. Okay, the other possibility where things could go wrong is if we have a discontinuous function. Let's say that here we have 1 and we have a function that does something like this. Okay, so we will have a local minimum, but because the function f is not continuous, then we will not have absolute minimum nor absolute maximum. Okay, you see here when we look at the plot, we see that it goes all the way up to infinity, so no absolute maximum, and then it can escape all the way down to negative infinity, so no absolute minimum. Okay, that is because the function is discontinuous even if we take the closed interval 0, 1. Let's look at one last example. Find the absolute maximum and minimum values of the function f of x equals x to the power 3 minus 3x plus 1 on 0, 3. Okay. F prime of x is 3x squared minus 3, right? I could just make equal 0. That will be if and only if x squared equals 1, which means x equals plus or minus 1. So there are two critical values, and there are no more because f is differentiable. So these are all the critical values. So we need to check negative 1, 0, 1, and 3. Okay, we need to check the critical values and the endpoints of the interval. So f of 0, f of negative 1, f of 0 is 1. F of negative 1 is 3. F of 1 is negative 1. And f of 3 is 19. So clearly x equal 1 is the absolute minimum, and x equals 3 is the absolute maximum.